Okay, problem number 5. Here we go. So we have a block that's attached to a spring, and the spring has a spring constant of 75 newtons per meter. This block is going through simple harmonic motion, which means it's basically starting here, it goes, it stops, it comes back, and it's basically bouncing back and forth between these two positions. This is known as our equilibrium point, and it says the max amplitude or distance from the equilibrium point is 17.0 centimeters. We are trying to find where is the max speed. And well, things that I know that the box has a force anytime that it has a displacement. I know that because of Hooke's law. Essentially it says force is equal to the negative spring constant times its displacement. And so at any time the mass times acceleration is equal to negative kx. I would like to know when it's not slowing down. As it moves away from this, this is going to give you a decrease in the overall speed of your object. It's going to give you a negative acceleration as x gets bigger. So the point that I care about is right there. That is the point where we're going to find the max speed. It's going to go the slowest here. And so we can look at this in terms of energy. Okay. This is conserving energy we have. So total energy initial equals total energy final. So we have an initial state. Our initial state is 17.0 centimeters away. That's its max amplitude. At that point, the velocity is 0. So total energy initial is going to be the potential energy of a spring. There is no kinetic energy, and I'm not changing height because it says it's a horizontal spring in the problem. I don't have to worry about that. My final energy, which is right at this point, there is no distance away from equilibrium, so there's no potential energy of a spring. And I know that because potential energy of a spring is 1/2 kx squared. Well, right here, x equals 0. So my final then is the only other type of energy, and that is kinetic energy, and that is 1/2 mE squared. So I can get rid of these halves. I know my k value is 75. My x value is 17 centimeters or 0.170 meters. And this is equal to the mass. Okay, and did I get the mass? Let's see. Does it give us me? Oh, it doesn't tell me the mass. Well, then I should put m here. And I will leave it in terms of m. Equals v squared. I didn't want to square root both sides. Okay? So let's find out what our answer is then. Our answer here is 75 times 0.170 squared. So that gives me 2.1675 over m squared. This is equal to v. I probably want you to take it one step further, but this would be a fine answer at this point, okay, because of that. And most likely on your test, I'd give you a mass. But if you want to take it one step further, you should take the square root of the top portion and get 1.47 divided by the square root of mass equals velocity. And this would be your answer, and this is now in meters per second. Now in your math classes, well, you're not supposed to leave a variable in the denominator. Well, I'm solving for a specific thing, so in this case it's okay. The nice thing about this style of answer, if I change this mass, let's say I make it 10, I can put 10 in there and solve. If I made it 20, I could put 20 and get my new velocity without additional calculation. So we do this a lot in physics. Good luck.